Good evening, students. So, how are you all doing? You able to hear me? Not clear. Huh? Oh, how is it now? Is it better now? I think I was very yeah. If I'm am I more audible? Clear now? Okay. So probably I was talking too soft, so you didn't hear. So today I decided on solving problems from the worksheet for squares and roots. Almost many of you, I mean all of you, had a feeling that you were unable to solve. Some felt it tough. Okay, so can we do that today? So squares and square roots. And when I saw your textbook chapter exponents, I found that, hello, is it better now? Is it better now? Now is it clear? Okay. So I heard from all of you that you are finding them difficult to do and all that. So, so we will work out those problems. And as I saw in your textbook, this exponents and radicals lessons, exponents lessons, I think we have completed everything. Um, so all the topics that are discussed in the text have been covered. We have done many problems in exponents and radicals. So I think it is time for you to take up a test in exponents. Correct, students? So I will plan and let you know when you will be taking up the test in exponents. I also want you to do the exercise problems of your textbook in exponents. I think you all have your book by your side. Do you have your books by your side? So there are three exercises in all, I think, right? Are there three exercises? Okay. Yeah, I am already speaking very loud. I don't know. Is it still not clear to you? I'm talking at my highest pitch right now. I cannot be any more louder. So if it is still not audible, please let me know. Okay. So your textbook. So there is exercise 2A, 2B. That's it. Only two exercises. Correct. Okay. Okay. So there are only two exercises. Uh, I want you to complete the first exercise of exponents chapter, because we have discussed every type of problem that is given in the textbook. Okay, so I would like you to now take up the two exercises as homework. Exercise 2A completion would be by Sunday this week. Okay, so you'll be submitting on Sunday. I'm giving you enough time. So that will be on the 5th of July. So on the 5th of July, you should be done with the first exercise of exponents. Okay? And the next exercise, you will complete by the 7th of July, which means I'm giving you a time of 1 week. You have to finish both the exercises, the textbook exercise problems, as homework. Okay? So by next Tuesday, I want everybody to send the answers to the two exercises. Is that clear to all of you? Okay. So that's for this week. You'll be completing both the exercises as homework, and you'll be sending your solutions by Tuesday, that is the 7th of July. Okay. So squares and square roots. Do you all have the assignment, the worksheet with you now? Okay. So no, see, I'm giving you a week's time from today. That is next Tuesday. See, initially I told you'll submit the first exercise by Sunday. But now I am giving you a week's time. I would like you to complete both the exercises by Tuesday next week, which is 7th July. Is that clear now? 7th July. Okay. So let's move on to squares and square roots. The first question, which of the following numbers are perfect squares? Which of the following numbers are perfect squares? All you have to do is to prime factorize every number that is given and see if you are able to pair the prime factors so that it forms a perfect square. Anyone has doubt in the first problem itself? Anyone who wants me to solve problem number 1? Okay. So second one, find the square roots of the following. Find the square roots of the following. See, again you have to do prime factorization. The last two problems which are decimals 420.25 and 0.007225. Only in those two problems probably you have some doubts as to how you should do. So what you would do is 420.25. This can be written as 42,025 divided by 100. Oh, you know that 100 is a perfect square. 100 is the square of the number 10, correct? Now, for 42,025, for this you need to do prime factorization. Now, I want to introduce to you a very interesting thing. Okay, so consider 1,225. Okay, so you can see that the last two digits is 25, right? 25. Look at the first two digits, it is 12. Will you be able to represent 12 as the product of two consecutive numbers? Will you be able to express 12 as a product of two consecutive numbers? Yes. 12 can be written as 3 times 4, correct? So, 1225, leave the 25, the remaining number which is 12 can be written as a product of 3 and 4 which are two consecutive numbers. So, the square root of this will be 35. So, the square root of 1225 is 35. So, this 3 and then the square root of 25 is 5. So, both combined it is 35. So, square root of 1225 is 35. Likewise, you can check many other numbers. Say for example, 625. Leave the 25. The first digit is 6. Can you express 6 as a product of two consecutive numbers? Yes, you can express this as 2 times 3, right? So the square root of 625 is, you'll take the first number with the lower number which is 2 and then 5. Likewise, for numbers ending with 25, you can check if this number can be written as product of two consecutive numbers. That's up to you. I don't want you to do it now, but you have to express this. If you see many such, there are, I mean, 1225, 625, so many other numbers are there. You can check. All right. 3025. 30 can be written as a product of 5 and 6. So the square root of 3025 will be 55. So like this. So this I'm telling you because this will help you in doing some problems. Like word problems, if you come across a problem where you have to find out the square root of 3025, it will be very easy for you to use this technique. Okay, is it clear? Okay, the third problem, write the ones digit of the square of the following numbers. What is so difficult about problem number 3? Ones digit. Okay, so let us take 12. What is the square of 12? 12 square is 144. What is the ones digit? It is 4, correct? That's all. You have to just square the number and find out the ones digit. I think you would have done this. Third one, did you all do? Okay, the fourth one. Find the least number by which 12,150 is to be multiplied to get a perfect square. Did you all do problem 4? Did you all do problem 4? Okay. So problem I want 12,150. Do the prime factorization of 12,150. Okay. I want you all to independently do this, please. So do the prime factorization of that. So 12,150 can be written as the product of 2, then 2 5s, and then 5 3s. Okay. So 12,150, you can write it as the product of 1 2, 2 5s, and 5 3s. So let us pair the numbers. 1 pair of 5, 2 pairs of 3, and what is remaining? A 2 and a 3. Correct? So had you had one more 2 and one more 3, you would have been able to pair the 2 and the 3. Correct? See, if there was one more 2 and one more 3, then you would have been able to pair the 2 and the 3. Correct? Hence, it would have become a perfect square. So, what is missing here is one number for this pair and one number for this pair. That is 2 as a pair, which means you need one more 2. 3, if you want to express as a, you need one more 3. Correct? So, totally you need a 2 and a 3. So, had you had this 2 and this 3, then you would have been able to pair. Correct? But then 2 and 3 do not appear in the prime factorization. So by what number you should multiply 12,150 in order to make it a perfect square? You need to multiply 12,150 by 6 to make it a perfect square. That's all. Did you understand, students? Is it clear now? Okay. Now leave 5, 6 and 7 for now. I want you to we in an order. 5, 6 and 7 need not be done now. Okay. I want you to try out problem number 8. Do the first subdivision. 12,283. Problem number 8, the first subdivision. Find the smallest number by which the given number must be divided so that the resulting number is a perfect square. It's very similar to this problem. So if the same problem had I given, by what number should 12,150 be divided in order to get a perfect square? Instead of introducing a 2 and a 3, even if you remove this 2 and remove this 3, this number would have been a perfect square. Correct? Instead of introducing 1 2 and 1 3 in order to pair these two lone numbers, had you removed the 2 and 3 also, you would have got a perfect square, correct? Which means if you divide this number by 6, you're getting a perfect square. So it is the same thing. You need to find out the number by which it should be divided. It is just the same thing. Instead of introducing the numbers, you need to remove those numbers which do not have a pair for themselves. Is that clear to all of you? I want the answer for this problem. I want every one of you to do. I'm quite problem for all of you. None of you are able to know what is going wrong. Let me check. Understood. Okay. So what I would do is to end this for a while, and I'll start a new live session, and I'll send you the link shortly. Okay. See, that is the only way that I can do, I think, because everything else seems